So in the last video, I said that we could transform vectors. And in this video, I want to show how we can use that same strategy to transform shapes. So we're going to be transforming polygons. So basically, if you have a vector in 2 dimensions, right? Basically, it's just a point, an XY coordinate distance from the origin, right? So I can essentially take each of the corners of my polygon, each vertex of my polygon, and I can write that as a point in a matrix. So for this question, this purple rectangle is the one we're transforming, and then we're going to be moving this green thing around to get it to the right spot. So I'm going to take each point of my rectangle and I'm going to make it into a matrix. So the first point is right here, this one that's being covered up. I'm going to move that because it's distracting. Okay. So I'm going to use this as my first point and I'm going to go this way. The order that you do it in does not matter at all. That's just what I'm doing. Okay, so I'm going to make my my matrix. So this point is 3, -3. So I'm going to write 3, -3. Sorry, it's so sloppy. Okay, so 3, -3. And then my next point is at 9, -3. And then 9, -6. And no, here, sorry. 3, -6. 3, -6 is the last one. Okay. Sorry again for that not being super straight. Okay. So then I'm going to multiply my transformation matrix times my points that are the vertices of my rectangle. So to do that, we're going to multiply first row times first column. So I'm going to write my resultant matrix over here. So first row times first column, -1/3 times 3 is just -1. 0 times -3 is just 0. So it's just going to be -1. Then I'm going to get my y coordinate, I'm going to do the second row times my first column here. So I get 0 times 3. And then 1/3 times -3 is just -1. So that's my first point. -1, -1 is my first point. So then I'm going to do that again. Now notice that because of this 0, I can kind of ignore that. So I'm going to start ignoring it. So for this next x value, I'm going to take -1/3 times 9 is -3. And then 0 times -3 is 0. So I can just ignore that. So I get -3. And then I'm going to do second row times second column. So I have another 0 here, so I can just ignore that. And 1/3 times -3 is -1. And now I have my second point. So then for my third point, I get -1/3 times 9. Ignore that. Ignore the 0. So -1/3 times 9 is -3. Second row times third column, I get 1/3 times -6 is -2. And then first row times fourth column, I get negative 1/3 times 3 is negative 1. And then second row, fourth column, I get 1/3 times negative 6 is negative 2. And now I have all of my points. So I can start plotting these. So I'm going to move these until I get them into their correct points. So I have my first point here is negative 1, negative 1. So I'm going to move, oops, I forgot to change back to the mouse. That would help. I'm going to move this to negative 1, negative 1. And then negative 3, negative 1. So I'm going to move this to negative 3, negative 1. And then negative 3, negative 2. And negative 1, negative 2. So this is my little rectangle. You can see we did it correctly. So I want to talk about this for a second, because what essentially just happened here, because the only things that weren't zeros were on this diagonal, then essentially what I just did is I just multiplied all of the x values by negative 1/3 and all of the y values by positive 1/3 is essentially what just happened here. And only because the only things that weren't zeros were this diagonal. Okay, so the only thing that ended up being multiplied was the top when we were doing the top ones and the bottom when we were doing the bottom ones. So when we have a situation like this, where we only have numbers besides 0 in this diagonal, we can kind of predict what's going to happen. So I have a negative 1/3 that's being multiplied to my x's. So my x's are going from positive to negative. So that's going to be a y-axis reflection, a y-axis reflection. So it makes sense that my box ended up on the other side of the y-axis. And then everything also became 1/3. So it makes sense that all of my proportions got shrunk down. So it's the same basic shape, but it's 1/3 the size that it was before. So that's some cool tricks that you can do with transformations. You can strategically pick what you want your transformation matrix to be in order to do interesting things with your shapes. So yeah, let's look at the next question. Okay, so this is another polygon, obviously. But the strategy is going to be exactly the same. Sorry, I don't like having them overlapping. The strategy is going to be exactly the same. I'm going to make a matrix out of all of the points. I'm going to multiply the matrices together. So this time I don't have any zeros, so it's going to take a little, it would take a little longer to do. But it's the exact same idea of making a matrix out of all of the points and then multiplying it by the transformation matrix and then plotting those new points. So hope that helps, and I will see you in the next video.